Hello, my name is Kevin, and I am part of the Global Public Health Scholars Program. For my practicum, I volunteered at the Johns Hopkins Hospital Department of Radiology under Dr. Ye Qiao. More specifically, I was in the Neuroradiology Division, whose mission is to teach, develop, and provide the most accurate diagnostic tests and treatments in neuroradiology. Now, radiology as a branch is concerned with using imaging techniques such as PET scans, CAT scans, or MRI to diagnose and treat diseases. Magnetic resonance imaging, or MRI, works by using strong magnetic fields, which are thousands of times stronger than Earth's own, and radio waves. The strong magnetic fields serve to line up the poles of the molecules, and then the radio waves disrupt them. As the molecules realign with the magnetic field, they send signals which can be read and recorded by the MRI machine. Because MRI is usually used to examine the brain and spinal areas, a high degree of precision is necessary because any minor change in brain or spinal function or the hardware can lead to very major changes in an individual's life. So an issue arises in which there are several MRI manufacturers, which include GE, Philips, and Siemens, and each of those companies makes several different machines as well. Because different hospitals, different research facilities will use different machines, the goal of this practicum was to verify the precision between different MRI machines. Now, this was done by first obtaining 8 volunteers who were each scanned on 4 different MRI machines. And those images were gathered and trimmed by postdoctorate students and Dr. Chow herself. Next up was image analysis, and the analysis was done on the vessel mass software, and it was done by analyzing the internal carotid, middle cerebral, basilar, and vertebral arteries. The analysis was done by measuring the vessel wall thickness as well as the vessel diameter. And then those results that were obtained were converted into a .txt file and then run through Excel for statistical analysis. The practicum was meant to either confirm or deny the precision between MRI machines, and hopefully by confirming the precision, though I did not see the results during my short time there, hopefully by confirming that we could use it safely. We could safely use it to diagnose and treat people, and then you can send them to different hospitals without a worry, or different research facilities without a worry that the data will be shifted because there are different machines or something like that. Now, because my time was very short, there were some big issues faced, one of which was time. I started off with an incomplete data set that was added to as I was analyzing the images. In addition, there was skilled labor required in order to actually take the MRI, as well as trim it and analyze it in depth. That requires a lot of knowledge, and that was provided by the postdoctorate students and Dr. Chow. In addition, MRI images could sometimes be a bit blurry as well, and then that made analysis particularly difficult because the thickness of the artery walls is not uniform around. And that could lead to some issues where sometimes you just have to take your best guess as to where the artery actually begins and ends. Potentially, it might be helpful to use a script in the future to automate that analysis process, but for now, we just have to stick to humans, just measuring by eye. And I want to give special thanks to Dr. Chow for mentoring me throughout this, as well as the several postdoc students under her, who also helped me during my practicum.